We're going to be solving systems of equations using elimination. A couple of hints. To eliminate a variable, the coefficient must be the same, but the signs must be opposite. That's why this is called using elimination to solve a system, because you will be eliminating a variable. For instance, when we say the coefficient must be the same, but the signs must be different, an example of that might be, I have a 6y and a negative 6y. Well, the coefficients, meaning the numbers, are the same, but the signs, positive and negative, are different. And when you do that, of course, that equals 0. So that's why you want your coefficients to be the same, but the signs to be opposite, because we need one of the variables to go away. When the coefficients are not the same, use the least common multiple to create coefficients that are the same by multiplying. So, like, if I had, say, 2 and 3 as coefficients, well, I can't eliminate them. So what I would do is I'd look for a multiple that they had in common. 2, 4, 6, and I use 2 and 3. So say my example is 2x and 3x. Well, 2 and 3, they're not the same coefficients, but I could make them the same by multiplying by something that they have in common. So I could go 2, 4, 6, 8, and then for 3, 3, 6, 9, and you can see that they have 6 in common. So I would multiply this 2 by 3 to make it 6, and make this one 2 to make it 6. Now I still have to make the other part true, where one is positive and one is negative. In that case, I could either multiply by negative 3 and make it negative 6, or I can multiply by negative 2 and make it negative 6. And that way I have a positive 6 and a negative 6. And sometimes it just means that you need to multiply by negative 1, especially if the coefficients are the same but the signs are different. Once you do that, you're going to add the equations to eliminate one of the variables and solve for the remaining variable. Then, once you get the value of that, you substitute that value of the solved for variable into one of the original equations. It doesn't matter which one, just one of the original ones. And then you solve for the variable that you eliminated. And the last thing you do is state the solution. So let's go ahead and get into it. We've got 2x minus 8y equals negative 10. Negative x minus 8y equals 17. Well, two things have to be true. We have to have the same coefficient, which we do for the y term, but the signs have to be different, and they're not. So I can simply multiply either equation by negative 1 and change the sign. So I have 2x minus 8y equals negative 10. And then here I have negative 1 times negative x, that makes that positive x. Negative 1 times negative 8y makes that positive 8y. Negative 1 times positive 17 makes that negative 17. So the 8y's are eliminated, and I'm left with 3x is equal to negative 27. So now I'm solving for the variable that was left when I added these two equations together. I'm left with x is equal to negative 9. Well, once I get that, then I can take this value, negative 9, and substitute it into either of these equations and solve for y. So I'm going to use this top one. 2 times negative 9 minus 8y is equal to negative 10. I've got negative 18 minus 8y is equal to negative 10. I want to eliminate the 18, or the negative 18 rather, so that I can find y. So I'm going to add 18 to both sides of the equation, and I'm left with negative 8y is equal to positive 8 divided by negative 8 on each side of the equation, and I'm left with y is equal to negative 1. So the last portion was to state the solution. Our solution is negative 9 in the x value and negative 1 in the y value. That's where the lines cross, and that is our solution. Now we're on the next question. We're looking for a variable to eliminate. We could eliminate x or we could eliminate y. Well, the easiest would be to eliminate y because we already have the same coefficient, which is 2, and the signs are already opposite. So I could just simply add these, and I've got negative 2x plus 3x is positive x. Those two terms are eliminated. Negative 6 plus positive 16 is equal, is equal to 10. So x equals 10. Now I'm going to substitute into either equation 10 for x. I'll use this bottom one. So 3 times 10 plus 2y is equal to 16. We've got 30 plus 2y is equal to 16. We're going to eliminate not eliminate the y's, but we're going to eliminate 30 so that we can get y alone. So we're going to subtract 30 from both sides of the equation, and we're left with 2y is equal to negative 14. Divide by 2 on both sides, therefore y is equal to negative 7. So that would be our ordered pair 10, negative 7. For number 3, we've got negative 2x minus 3y equals 10, and then we've got 2x plus 2y equals negative 2. Again, the coefficient for x is the same this time, and they are opposite signs, so we can just add them together. The x's eliminate, and we're left with negative y is equal to 8. We don't want negative y, and we know there's an imaginary 1 in front of that y, so we can divide each term by negative 1. That gives us y is equal to negative 8. We still need the x term, so again, pick either equation and substitute negative 8 in for y. So I'm going to pick this bottom one. We've got 2x plus 2 times negative 8 is equal to negative 2. So 2x minus 16 equals negative 2. I want the x's alone, so I'm going to first eliminate 16 from both sides of the equation. I've got 2x equals 14. We're going to divide 2 by 2 and divide 2x by 2. That leaves us x alone equals 7. So our ordered pair where the lines cross and the ordered pair that makes both equations true would be 7, negative 8. We've got 10x plus 9y equals negative 19. And then we've got 7x plus 9y equals 11. Now, again, you could eliminate either x's or y's, but we want to go the easiest route possible, and that would be where we have the 9's. Because we already have the same coefficient, we just need opposite signs. So we could multiply our second equation by negative 1. We rewrite our first equation, and then we multiply every term in the second equation by negative 1. So that gives us negative 7x minus 9y equals negative 11. And now we can add them. So we've got 10x minus 7x, which gives us 3x. 9y minus 9y is eliminated. And negative 19 plus negative 11 is negative 30. We're still solving for x, so we're going to divide each side of the equation by 3. That leaves us with x is equal to negative 10. So again, you take your value for the solved for variable and choose either equation to substitute in negative 10 for x to solve for y. So we've got 10 multiplied by negative 10 plus 9 multiplied by y equals negative 19. Well, that's negative 100 plus 9y equals negative 19. We want to eliminate the 100, so we're going to add 100 to one side and to the other side of the equation. That 9y is equal to positive 81. Divide by 9 on both sides of the equation. We've got y is equal to 9. Therefore, the solution to our system of equations would be negative 10, comma, 9. Alright, in this equations, or these two equations, we have 8x plus 2y equals 8, 4x minus 2y equals negative 20. Again, we're looking for where the coefficients are the same, which is the y term, and the signs are different, so we really don't have to do anything but add the two equations together. We get 12x, the two y's eliminate each other, and we've got negative 12. Divide by 12 on both sides of the equation. Therefore, x is equal to negative 1. We take our value of x, which is negative 1, and choose either equation to substitute that value. So I'm going to choose the second one. 4 times negative 1 minus 2 times y is equal to negative 20. That negative 4 minus 2y is equal to negative 20. I want to eliminate the 4 so that I could start getting y by itself. So that minus 2y is equal to negative 16. Divide by negative 2 on both sides of the equation. Y therefore is equal to negative divided by negative is positive. So that would be positive 8. Therefore our solution would be negative 1, comma, 8. Alright, on question number 6, we've got 5x minus 5y equals 10. Negative 6x plus 5y equals negative 18. We're looking for the same coefficient with opposite signs, so you can see the y term already has that. So we can simply just add our two equations together. 5x minus 6x is negative x. The 5y's eliminate each other. 10 minus 18 is negative 8. We're going to divide each term by negative 1 because we know there's an imaginary 1 in front of that x term. So a negative divided by a negative is a positive. Negative 8 divided by negative 1 is positive 8. Therefore, x is equal to 8. Choose either equation which to solve for y by using the value of x. So I'll just choose the top one here. 5 multiplied by 8 minus 5 multiplied by y equals 10. Well, 5 times 8 is 40. Minus 5y is equal to 10. I want to eliminate the 40 from this side of the equation. So I'm going to subtract 40 from both sides of the equation, and I'm left with negative 5y is equal to negative 30. Because all I did was 40 minus 10. And negative 40 is bigger, that's why that happened. Then I divide by negative 5 on both sides of the equation. Y therefore is equal to 6. And our ordered pair where the lines cross, also known as the solution, then would be 8, comma, 6. Now we have 9x minus 7y equals 10. Added to that is negative 9x plus 9y is equal to negative 18. And the reason why I said added to that is because my coefficients on the next term are the same, 9 and 9, but my signs are opposite. So there's no other multiplication that I need to do. I can just eliminate the x's. And I've got negative 7y plus 9y. That gives me 2y. 10 minus 18 gives me negative 8. We want the y alone, so we're going to divide by 2 on both sides of the equation. That gives us y is equal to negative 4. Choose either equation, and we're going to substitute negative 4 in for y. So I'll just take the first one. That's 9x minus 7 multiplied by negative 4 is equal to 10. 9x plus 28 is equal to 10. We want to eliminate the 28 so we can start getting the x by itself. So we're going to subtract 28 from both sides of the equation. That leaves us 9x equals negative 18. We divide by 9 on both sides of the equation. Therefore, x is equal to negative 2. So the ordered pair that makes this equation true or makes both equations true, would be -2, -4. It's also known as the solution, or where the lines cross. We've got -5x plus 4y equals 4. X minus 4y equals -20. And again, we're looking for the same coefficient with opposite signs, and we have that in the y term, so we can eliminate that automatically. Go ahead and add these two equations. So we have -4x is equal to -16. Divide both terms by -4. Therefore, x is equal to 4. We're going to take our value of 4, place it into either of the equations. I think I'll use this bottom one. So I've got 4 minus 4y is equal to -20. I want to start getting y alone by eliminating the 4 on the left side and adding it to the right side of the equation. So we've got -4y is equal to -24. I just added those together because the signs were the same. And we're going to divide by -4 on both sides of the equation. That leaves me y is equal to +6. Therefore, our solution would be 4, 6. And we've got -9x minus 4y equals -10. -9x minus 7y equals -4. Again, we're looking for the same coefficient with opposite signs. Well, the x term at least has the same coefficient, although the signs are not opposite. The y terms, the coefficients are the same, and the signs aren't opposite. So let's go ahead and eliminate the x. I'm going to take the bottom equation and just multiply it by -1, because what we know will happen is that the signs will change to their opposites. So I just rewrote the first equation. Now I've got -1 times -9x gives me +9x. -1 multiplied by -7y gives me +7y. And -1 multiplied by -4 gives me +4. Now I can eliminate the x terms, and I'm left with 3y is equal to -6. We divide by 3 on both sides of the equation. Y therefore is equal to -2. Then I choose either equation, and I'm going to substitute -2 in for y. So I'll just use the top one here. So -9x minus 4 multiplied by -2 is equal to -10. -9x plus 8 is equal to -10. I want to eliminate the 8 because I'm trying to get x alone. So I'm going to subtract 8 from both sides of the equation. That leaves me -9x is equal to -18. Divide by -9 on both sides of the equation. X therefore is +2. So we've got 7x plus y equals 6. 7x plus 4y equals -18. My coefficients are the same here, but my signs are not opposite. So I'm going to multiply my bottom equation by -1. I'm going to leave my top equation alone. So -1 times +7x gives me -7x. -1 times +4y gives me -4y. And -1 times -18 gives me +18. Now I can add the equations together. The x's are eliminated, and I'm left with -3y is equal to 24. Divide by -3 on both sides of the equation to isolate the y or get the y alone. Y therefore is -8. Take your -8, choose which equation you'd like to substitute inside of to find x. So I'm choosing the top one. I've got 7x plus -8 equals 6. I could have just as well written this as 7x minus 8. As a matter of fact, I think I'll do that. 7x minus 8 is equal to 6. I'm eliminating the 8. from the left side of the equation. So I've got 7x is equal to 14. Still don't have x alone, so I'm going to divide by 7 because that's what's in front of my x value. And what we see is that x did finally equal 2, and then we have 2, negative 8 as our solution. And you may be wondering what happened. My computer ran out of space, so I had to delete some stuff. I'll be right back. Alright, we've got 10x plus 5y is equal to negative 10, and negative 5x minus y is equal to 20. Now, notice we've got the 10x plus 5y equals negative 10, and I'm going to multiply this entire equation down here by 2. That gives me negative 10x minus 2y, and then 2 times positive 20 is equal to 40. So right there. Eliminates the x's. That leaves me 3y is equal to positive 30. Divide by 3 on both sides of the equation. And that gives me y is equal to 10. Take either equation and substitute the y value. So I'm taking the first one. I've got 10x plus 50 is equal to negative 10. I'm going to eliminate the 50 from both sides of the equation. That leaves me 10x is equal to negative 60. We're going to divide by 10 on both sides of the equation. Therefore, x is equal to negative 6. And our solution will be negative 6, 10. One more. Alright, on this one I've got negative 5x plus 6y equals negative 7. Negative 3x minus y equals negative 18. Again, you see our coefficients aren't the same. So what I'm going to do is multiply every term in the second equation by 6. I'm going to leave the first alone. So I've got negative 5x plus 6y is equal to negative 7. Then I multiply 6 times every term inside the parentheses. That gives me negative 18x minus 6y. And then, let's see, 18 multiplied by 6 is 8, 108. So that would be equal to negative 108. So I've got negative 23x is equal to negative 115. We're going to divide by 23 on both sides of the equation. X therefore is equal to 5. So x is 5. Let's solve for y. I'll pick the first equation. Negative 5 times 5 plus 6 times y is equal to negative 7. We've got negative 25 plus 6y is equal to negative 7. We're solving for y, so we're going to eliminate 25 from the left side of the equation and add it to the right side. That 6y is equal to 18. Divide by 6. Got ahead of myself. Y therefore is equal to 3. So our ordered pair that makes both equations true. Therefore, it's the solution to the system is 5, 3. All right, we got it to 80. You take it to 100. Talk to you later.